As you may be aware, in recent years, requirement for multimedia has largely increased in areas such as medicine, telecommunication, entertainment, security, etc. Multimedia, to begin with, is a combination of multiple sources of video, audio, and images. Video stream data hierarchy. I will first explain the theory behind the practicality of video coding. A video is used for recording with the intention of showing moving objects. It is made up of a group of pictures taken at regular temporal intervals. You can break up a video frame into rectangular areas known as slices or tiles. Each tile slice is then broken up further into square units known as macro blocks. A video codec will technically process a clip one macro block at a time. Motion compensated hybrid coding. A codec is basically a combination of a decoder and an encoder. A codec is a mathematical way that light is transcribed in case of a video and sound in case of audio, and transform it from its analog world, which is what we see and hear, into a form that a computer can read, which is ones and zeros. First of all, an encoder needs to communicate with a decoder and should be compatible with each other for it to work. When partitioning a video, you're breaking it into units to be processed in the video codec. These units will be processed into three components: the Y, CR, CB. The Y component, which is a rough map of brightness of the picture presented, and the CR and CB, which are the red and blue color components. The color components are stored within half the resolution of the Y component. This is because our eyes are sensitive to brightness and color. The encoder then makes a prediction of the next block and subtracts the prediction from the previous block. This then transformed and quantized, and the information that is not important is discarded. Our result is then put into the entropy encoder, which then organizes and compresses the data into a binary form. The decoder simply just reverses these stages and made up.
The Impact 1 standard was designed in 1992 to achieve suitable video quality at 1.5 megabit per second and 352 by 288 divided by 240 pixel resolution. Impact 1 is playable in almost PCs and DVD players. The Impact 2, developed in 1993, supports standard definition resolution as well as high definition video signal with a pixel resolution of 1280 by 1080. The H263 standard, developed by the ITU in 1995, was for video conferencing at low bit rates for mobile wireless communication. Human perspective. Color space. Representing color requires multiple numbers per sample. The well-known system to represent color is a color space. Two of the most common color space for digital image and video representation are RGB and YCRCB. However, RGB is not suitable for compression since it doesn't consider the perception of humans. In addition, YVU color space for Y can only give the grayscale image. In fact, human eyes is more sensitive to change white, and this is used in compression. The human ability of perceiving motion is due to the well-known phenomenon of persistence of vision, in which an image stimulation continues in the retina for a fraction of a second beyond the initial exposure to stimulation. When successive similar images are shown rapidly so that the rate is higher than the critical fusion frequency, the images appear merged together so that the viewer perceives a motion.
The H.264 video coding standard is a video compression technology and is also the most commonly used codec on the planet. It was jointly developed by the ITU and iOS/IEC. H.264 can be incorporated into multiple container formats and is frequently produced in the MPEG-4 container format, which uses the MP4 extension as well as QuickTime MPEG transport, etc. MPEG adopted H.261 and JPEG together to form what is called a suite. The specific name for this first suite is MPEG-1. It was limited to 1.5 megabits, 420 and stereo audio only. MPEG suites have subdivisions called parts. Part 1 is always for the system file format, Part 2 is for video, and Part 3 is for audio. In 1999, technology had advanced enough to warrant an upgrade of the suite. MPEG 2 Part 2 or H.262 had additional support for interlacing and 422. Most of broadcast television adopted MPEG 2 and is still the most widely used codec today for broadcast. MPEG 2 also had more than 3 parts. The most important of these is Part 7, called the Advanced Audio Coding audio format. H.264 has a high compression rate. It is about 1.5 times more efficient than MPEG-1 encoding. This high compression rate makes it possible to record more information on the same hard disk. The image quality is also better and playback is more fluent than with basic MPEG-1 compression.
The H.264 video coding standard provides new and improved features that enables much more efficient video compression. One of the major features provided by H.264 is the improved interprediction. H.264 also provides flexibility as it allows the use of multiple reference frames. This enables opportunity for more accurate interprediction and also improved robustness to the loss of picture data. H.264 includes several features that can efficiently contain the impact of errors. In H.264, the spatial segment is independent from its neighbors, thus errors or missing data from one slice cannot propagate to any other slice within the picture frame. This increases flexibility. The partitioning of data is supported to enable higher priority data to be partitioned from lower priority data and hence improving efficiency. H.265 is capable of data compression approximately double the ratio of H.264 at the same level of video quality, or substantially improve video quality at the same bitrate, doubling the coding efficient and reducing bandwidth usage by 70 to 80%. H.265 also supports 8K UHD rather than 4K in H.264. H.265 also provides a significantly higher frames per second of up to 300 FPS, almost 5 times more than that of H.264, of up to 59.94 FPS. This illustration displays the use of the traditional H.264 standard. Each macro block is fixed. In H.264 coding technology, each block of data is completely independent to each other. So coding distortion situations are likely to happen on the border areas of the giant block. This illustration displays the use of the H.265 standard. The size of the code unit is determined by the regional information. From the image contrast, we can see that the image quality enhances significantly in comparison to H.264.